Welcome to the DIY Honda Garage channel. The DTC P0340-31 represents a malfunction where the Camshaft Position Sensor A, often abbreviated as CMP Sensor A, is not sending a signal to the Powertrain Control Module, PCM. This sensor plays a pivotal role in the vehicle's engine management by providing essential data regarding the position of the camshaft. The PCM utilizes this data for fuel injection timing and ignition timing. A lack of input signal from this sensor leads to improper engine performance, potentially causing stalling or difficulty starting. The CMP Sensor A is located near the engine assembly, typically close to the camshaft, and connects to the PCM via wiring harnesses. When the PCM detects that it is not receiving the expected signal, it logs the P0340 code, indicating an anomaly that should be resolved promptly to maintain optimal vehicle function. The DTC P0340-31 indicates that the Camshaft Position Sensor A is not transmitting a signal to the PCM, resulting in the PCM registering a fault condition. This signal is vital as it assists in determining the camshaft position, which is necessary for proper engine timing and operation. The absence of this signal can hinder the engine's performance, leading to potential stalling issues or difficulty starting the vehicle. The CMP Sensor A is located within the engine compartment, usually mounted near the camshaft, ensuring it accurately reads its position based on the camshaft's rotation. The PCM, which serves as the vehicle's central computer, evaluates this sensor's output to manage functions such as fuel injection and ignition timing. Disruptions in this signal require immediate attention since they can significantly impact engine performance and efficiency. Several possible causes can lead to the P0340-31 DTC. The primary suspect is a malfunctioning CMP Sensor A, which may fail due to internal component issues or external environmental factors. Wiring issues within the circuits connecting the sensor to the PCM can also cause signal disruption. This includes frayed wires, disconnections, or shorts within the harness. Furthermore, a defective PCM may lead to inaccurate readings despite the sensor's functionality, thus incorrectly registering this DTC. Lastly, poor electrical connections at any junction, including at the connectors of the CMP sensor or the PCM, can obstruct proper signal transmission. Identifying the exact cause is crucial, as it will influence repair strategies to ensure the integrity of the engine's control systems. Symptoms associated with the P0340-31 error can manifest in various forms. One common symptom is engine stalling. This can occur unexpectedly during idle or while driving, leading to significant safety risks. Additionally, the vehicle may exhibit difficulty starting, where the engine cranks but does not start, or it requires multiple attempts before successful ignition. Poor acceleration performance is also common. Drivers may notice sluggish responses when pressing the accelerator pedal, impacting drivability. Furthermore, the check engine light will typically illuminate on the dashboard, prompting the driver to investigate the underlying issues. These symptoms not only hinder the vehicle's operation, but can also indicate broader problems with the engine management system, necessitating immediate diagnostic intervention. In the first troubleshooting step for DTC P0340-31, you should start the engine to observe the behavior of the CMP Sensor A. The intention here is to check for the signal input from the sensor to the Powertrain Control Module. A functioning sensor will send a pulse signal that the PCM interprets correctly. If the PCM receives no signal, it likely indicates an issue with the CMP sensor or perhaps a related component in the circuitry. It's critical to evaluate how the PCM responds during this phase. If the engine behaves normally and there are no DTCs other than the P0340, the next step would be to inspect the CMP sensor A itself and its wiring for visible defects or connection issues, as these are common culprits of signal failure. For the second step in troubleshooting DTC P0340-31, you need to inspect the CMP sensor A directly. Start by examining the sensor's connector for any signs of damage, corrosion, or loose connections that could disrupt the electrical flow. This sensor typically connects through a wiring harness, so checking the condition of the wires leading to it is equally important. Next, you should measure the unit output voltage while the ignition is in the on position, but the engine is not running. It should ideally show around 5.0 volts. If the voltage is within this range, it suggests that the CMP sensor A is likely functioning correctly, separating it from the issue. However, if the voltage reading is abnormal, this indicates a potential failure of the sensor itself, warranting replacement. In the third troubleshooting step for the DTC P0340-31, you will conduct a thorough inspection of the VCC2 and TD-CAM circuit connections. Begin by ensuring the CMP sensor A connector is disconnected, and also disconnect the PCM connector B. This will allow for accurate resistance measurements. Check that the circuits show less than 1 ohm of resistance when the ignition is off. This indicates that the wiring is intact without any breaks or shorts. The SG2 circuit should also be verified, as issues here can affect the signaling process. Next, you need to measure the resistance of the TD-CAM circuit to ensure it is not shorted to ground. Any anomalies in resistance readings could signal a wiring fault or circuit damage, which should be addressed to restore proper function. The final troubleshooting step for DTC P0340-31 focuses on the powertrain control module itself. If previous tests indicate that all other components are functioning normally, assess the condition of the PCM, looking for damage or logical failures that could contribute to the lack of signal from the CMP sensor A. If earlier inspections returned results showing that the sensor and circuits are operationally intact, then the PCM is likely the source of the problem. It may fail to process signals correctly due to internal faults, and such issues often require replacement or reprogramming of the PCM. Properly diagnosing the PCM is crucial, as this module orchestrates multiple systems within the vehicle. Ensuring its functionality is vital for restoring normal vehicle operation. To verify the repair after addressing the DTC P0340, it's essential to clear any stored diagnostic trouble codes using Honda's diagnostic software. After the DTC is cleared, a test drive should be conducted to allow the vehicle systems to re-evaluate performance parameters. During this test drive, closely monitor the engine behavior and observe for any reoccurrence of the check engine light. Additionally, it's important to keep track of the data from the engine performance. Ideally, there should be no faults recorded during this phase. If any issues continue to arise, additional investigation may be warranted, possibly revisiting previous troubleshooting steps. Verification is critical in ensuring the initial issue has been effectively resolved and that the vehicle operates reliably. To prevent future occurrences of DTC P0340-31, regular maintenance practices should be implemented. Scheduling periodic inspections of the Camshaft Position Sensor A can identify potential degradation or damage before they result in failure. Additionally, ensuring that wiring is free from fraying or corrosion through thorough checks coincides with these inspections helps maintain signal integrity. Clean connections and wiring are key to robust performance, so employing dielectric grease on connectors can prevent moisture ingress. Furthermore, manufacturers often release software updates for the PCM. Ensuring that the vehicle is up to date can enhance performance and address any known bugs that might lead to erratic behavior. Adopting these preventive measures ensures that the engine management system is reliable and reduces the likelihood of issues arising in the future. In conclusion, the DTC P0340-31 highlights the importance of the Camshaft Position Sensor A in vehicle operation. Understanding how this sensor functions and the critical role it plays in the engine management system is essential for prompt repairs. Thorough diagnostics are crucial in isolating the root cause of the issue, whether it's a malfunctioning sensor, wiring problems, or a faulty PCM. By following a structured troubleshooting approach, technicians can efficiently rectify the problem. Additionally, implementing preventive maintenance strategies not only enhances vehicle longevity, but also promotes optimal engine performance and minimizes future troubleshooting needs. Awareness of these elements contributes to the overall reliability of the Honda CR-V and focuses on sustaining its performance standards. Please like and subscribe to the channel. See you next time.